All right. So what we're going to do is we are going to do a little bit of debugging. So for those that don't know, one of the reasons why my corruptions are really good is I know quite a bit about debugging. I know how certain architectures work, and I kind of know how a little bit of assembly coding here and there, and that's why my Genesis corruptions are great. Um, but when you have to figure things out like sound samples and compressed graphics, that sort of thing, you kind of have to know a little bit about how the code works. So, a little bit of a backstory here. Let me unpause this if it'll let me. Hey, oh, what the hell is it? Oh, I've oh that's funny. I've actually debugged this before, so that's why it keeps pausing. There it goes. Okay, so we'll get to breakpoints later. So basically, there was someone on Reddit that hello everyone. There was someone on Reddit that wanted to like an endless mode B. So for those that are unfamiliar with NES Tetris, mode B is something that I just now realize that this is really late and my wife is going to like kill me at some point. Audio good, guys? Hopefully it is. So I'm going to turn that down for myself though. So I got to be quiet. So anyways, so endless B mode. So how do you do that? How do you get it it doesn't so that it doesn't count down? Well, the best way to do that would be to figure out how it counts the counter down each time you get a line and just disable it. Or, just something along those lines. We usually use like what we call a no-op instruction, and that will like do nothing. So, so there are a few things to consider with this. First off, we have to find the memory location that has that counter. Then we got to put a breakpoint and figure out the code that's modifying it, and then we got to make a Game Genie code, and then it should be good. So, oh, hey Reddit person, how are you doing? So you're going to get a crash course in debugging. So let's go ahead and get started here. First off, so let me go ahead and grab my controller here. So we're going to start a B type. So we got 25 lines, and as you can see, I have nothing up my left sleeve, nothing up my right sleeve. It's going to go and do, as if I can get something that doesn't suck. All right, so this should be 24 lines. All right, so let's pause there. So what we're going to do is we also want to get like a calculator. Calculators are nice. Calculators are fun, and in case fuck, that's huge. All right, hold on one second. Let me scrunch that down a bit. All right, so nice thing about calculators, Alt 3, I think. No, I'm sorry, Alt 4 is your programming calculator. So for those that don't know, computers handle things mostly in like hexadecimal, which is base 16. So 24. That's decimal, obviously. So if we put in 24 here, what's going to be in memory is going to be the value of like what we would call like 18 here. So that's what we would want to look for. And we would want something that will show that decrementing 18, 17, 16, 15. So we're going to take just a quick look at the shit, where is it? No, I think I have to be in here in the memory viewer. Here we are, memory tools. So, let's get a quick rundown here. You got CPU memory. That's all the memory that CPU uses, from like I think 0 to 7FF, I believe. You got PPU memory, which is just graphics. We don't care about PPU memory. We're not going to be fucking with the PPU. Program ROM. That's going to be important because the code is going to be there. Usually, there are some cases where code is in memory, but this is Tetris. It's pretty basic shit. It's going to be in program ROM. Work RAM is just extra memory. Tetris doesn't use that, I don't think. Then you've got your character ROM, again, graphics don't care. Name table, that's PPU. Palette PPU. Sprite PPU. Secondary OAM PPU. So we'll go to CPU memory here. So like I said, the first thing to determining how this works is you got to find the values that you want. Sometimes you can just look, and that'll work. So if I start playing this, you'll see a whole bunch of values, change. So kind of transparent calculators are cool. So in any case, so if we had this running, you'll notice that shit's happening in the background. So So some of these are timers, some of these are keeping track of the pieces, some of these are random number generators, that sort of thing. I think memory location 17, you notice that a lot of that's very random. It's probably a random number generator right there. So we said 18. Do we see an 18 anywhere? Anywhere at all? I'm kind of just like looking and trying to play at the same time. So I'm going to try that first, and if not, we're going to try a bit more thorough approach where we start doing like memory searches and whatnot. But I wanted to see really quick if we can even see it. I can see the position of the Chichamino, which is pretty cool. So it's probably around there somewhere. No, not yet. So again, I'm still trying to see. So it might not be in 0 page. So this whole thing. Okay, you can see my mouse pointer. So this whole thing from here to here is what they call 0 page. And the reason why that's important is because it's a lot faster to do calculations on 0 page just because of how things work, how 6502 works. So it takes less time to execute a command that references memory in this small little region than anywhere else because it can be represented in 1 byte instead of 2. So, let's see here. Tetris does use an extra bank. Well, yes. I think it uses extra character ROM, I think. But I think it fits all of its program ROM into like 1 bank. So again, but we don't care about character ROM. We're not doing graphics. We're doing code. So if we scroll down, so I'm gonna scroll down here a bit because I'm not finding it anywhere. It might be in one of these, I think. So, oh, we're at 22. So that's 16. So if we look around, I'm going to see if I can find 16 through here just really quick. If not, I can't remember if Messin has. I don't think it does. I would have to load up. A cheat like BizHawk or FCEUX in order to get like cheat tools. Cheat tools help considerably. But let's see if we can find. Let's do this. Let's look for the values of like 16 here. So we have so 6B0 has the value of 16. So let's watch that really quick. So see what happens if we remove a line and see if that changes. No, it changed to something else entirely. Okay. So I really need a cheat device. Hold on 1 second. So if I lose you guys at any point, let me know. Because I'm explaining things that I have. That's not what I wanted. I clicked on the wrong damn thing. What is this? Why did it freeze Messin? Go away. Oh shit! I didn't want to click on that. I don't know what History Viewer does. I'll wait for the program to respond. Will it respond, or am I gonna have to reload it? So what we may have to do is we may have to use a different emulator because Messin doesn't really have like memory search tools. I don't think. That's the one thing about Messin that like it has a beautiful, amazing debugger. It's one of the best debuggers I've ever used. But okay, hey, it fixed it. It recovered. So let me look at cheats here. I can't remember. Oh, hello. Okay, so it does have this. So all right. So we want to reset. So current value is. I'm just gonna cheat here. Current value is 13. Okay. Wait. Hold up. Is this in? Is this in? Oh no. It's in decimal. So we actually want to use 19. All right. So add filter. Oh, whoops. Reset. Probably would help if I did equal to 19. Okay, there are literally 2 values that have that. So let's like watch both of them. Let's start with the value 1a. So this I think if we I don't think it's it. So it's where is it? Debug. Oh, we want to run one frame. So this is going to be, oh, still 13. Okay. So what happens when we play? So what happens if we, oh, that's, okay, I think that's counting how many, yeah, it's counting how many, okay, so it's counting how many pieces have dropped, I think. Okay, so that's not it. Where's the cheat thing? Okay, so this is, so let's look at 709. So that still looks like it's 13. So that's might not be it either. So, yeah. So this is interesting because now I'm wondering, how does it figure out? So there's another thing that it could be doing. It could be doing like some sort of BCD thing where it doesn't internally store the lines in like a how to put this? I think I had, hold on. For some reason the line counter counts up and down like a regular number, not like hex. This is 24, not 18. I had trouble finding it because of that. Oh, that's interesting. Huh. So it probably uses some sort of weird BCD bullshit. So let's try something else. Let's try something like start looking for something like this. Okay, so we have 0104 down here. Are there any other? Oh goodness! Oh no! Let's go back. Let's go back. Back. Oh my God! Hold up. Oh, let's go. Let's just do this and go like this, and then go next. So it's probably not it. What about? It could be Little Indian, so it could be like. No, that's not it either. Okay, so let's try a different approach here. So we're going to reset this, and then what we're going to do is oh, current value. Okay, so previous value. Okay, gotcha. So actually, let's do this. Let's reset. We're just gonna start from. Oh, is it gonna crash? Messen tends to be unstable sometimes. We'll see what it does. I don't know why Messen has issues, but it does sometimes. Come on, recover. Cover, you piece of shit. I have a love-hate relationship with Messen, by the way. I use Messen for my ROM corruptions these days, and sometimes it just doesn't want to play nice. Don't know why. Don't know why. And it sucks. It's at, yeah, I knew. Okay, so I heard, yeah, I remember hearing about that. Okay, so is that this? All right, so thanks. So it is in BCD format. What the hell? It's in decimal. No, seriously, what in the mother of God? Well, let's see. Yeah, you're right. Why is it in BCD format? That is so fucked up. That's so fucked up. So here's the interesting thing. It's stored in both 50 and 70, so it's going to be one of these two. So what we're going to want to do is we're going to want to look at the code and figure out why it's doing both. For some reason, in case you haven't like noticed, like 60 through 6F is like a mirror. You know what? Rewind. Here I am just yapping and I'm like playing terribly. So yeah, that's really strange. So yeah, that's really weird. And here's the thing. I think this is constantly being either read or written to. So if we were to put like a break, so CPU memory. Yep. All right. So it's loading. Okay. So all right. So let's go over. Let's go over registers really quick. So this, okay, so this is kind of weird. I don't know why they do this, but they do for some weird reason, and I don't know why. But apparently, they take all the values from like 60 to like 6F and load it into 40 to 4F. Don't know why they do it, but they do. So let's look at this code just really quick, and this is just going to be a quick crash course in 6502 assembly. So basically, what this is doing is let's go over registers just really quick. So A is your your accumulator, which is basically the register where all the math happens. Basically, you add, subtract everything to A. So registers are just temporary values stored internally in the processor. X and Y are usually index registers, so they're used for loops and other things like that, and offsets for addresses, hence index. And PC is where the code is currently running. So, and these are status registers. These are important for things like branches and whatnot. It's like, so which direction the code should go with conditional branches. So yeah. And then you have a stack, which is basically a temporary location for addresses and whatnot. So, so yeah, that's kind of long and short of it. So if you see here, this is a load instruction. So it's putting a value into the register. Store instruction is taking something from the register and storing it at like a memory or some sort of address register, something like that. So, was written using libraries and Nintendo had lying around and shoehorned them because the game was apparently the game that had to be done in a month. Citation needed. Wouldn't shock me. But yeah, it's very weird that it's not stored in hexadecimal. That's very, very strange. So they have to do some special routine to make sure that it doesn't go to like from 0 to F. It has to go from like 0 to 9. So they probably have some like some magic that does that. Yes, it is. It is 6502 assembly. So basically, I'll give you like a quick rundown of what this does. So it loads 1F into X. Then it's like, hey, take 1F, so 60 plus 1F from here, and load it into here, and then take that same value and store it into 40 plus 1F. This is a decrement, so this reduces the number by 1, and then if it is below 0, then exit from the branch, basically. So that's actually a really stupid way to do that, because I mean, there is a branch instruction for like overflow or underflow. What the fuck were they doing here? This doesn't make sense. There is literally a branch instruction. Good job, Nintendo. Way to be stupid. All right. Funny words, Magic Man. No, I shit you not. There is literally like a branch on. I'm trying to remember. Like a branch on negative would have like worked. Like really, or I don't know who made this code, but I want to smack them. Anyway, so okay, but the long and short of it is this is a loop that copies everything from backwards, copies everything from 40 to copies everything from 60 to 40. So since we know that this is kind of like a copy, basically, and that the good stuff is at 60, then we definitely want 70. So 70 is our little magic place here. So let's get rid of this. Well, let's edit it and put instead of 50, 70. Like that. So, boop. All right, so now let's run it again. And it's probably going to, okay. So, what the fuck is this doing? So, load from 40, and this is like doing the exact opposite of what it did before. See, this is the fun part of debugging. There's a whole bunch of shit where it's like, I don't know what the fuck this is doing. I don't know why they're doing this. And then you find the code that you want, and then this is fun. All right. Yeah, it's not gonna. Yeah, no shit. So 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 this is a problem. So what we need to do now is we need to um we need to start we need to like ignore um these types of instructions. And what you can do is you can do something called conditional breakpoints, where you break on an instruction or on a memory address, but say don't bother if you're like if it's this piece of code. So we know that this is A7B2. And we know this is bullshit because it's just copying over from one to the next. So we can go in here, and I think if we do PC is not equal to, I'm trying to remember what's the program counter. I think I have to do okay. So we have to do this to indicate hexadecimal, and then 87B2. So like that, and that will tell the debugger, hey, break on this, but just as long as the program counter, which keeps track of where we are, does not equal this, so that it won't break here anymore. So you guys follow me so far? So like that, okay? So let's see what happens when we run it. So we also want to do it for 8788 because that was the other bullshit one. So we go in here, and I think I can just do a new line. Hopefully I don't have to like do anything stupid. Will this be, let me guess, I have to add a semicolon? Oh, I know why. I'm an idiot. Oh, it still doesn't like it? Hold up. Oh, this might help. I think I have to have conditionals. There we go. So if it equals that or that. So now we've got, so what happens when we play it now? Why isn't that working? It's been a while since I've done debugging, but yeah, it's still trying to any yes, it can be extremely hard to understand. Yeah, so what does debugging a game do? Yeah, we're trying to change the mechanics. We're trying to find the code that decrements the lines. So we gotta find the right code for that. But right now I'm trying to figure out why the fuck this isn't working. Let me look at this again. Hold on. So PC, I could have sworn it was not equal. So hold on here. Why is, hold on one second. Oh, address program counter. Previous instance branch cycle scanline frame value is red is right address ROM address. Damn it. Maybe. How about this? I'm gonna try something here. I'm gonna do this a little bit smart. I'm gonna let's see here. Maybe if x, because I don't think. I mean, I could be wrong here, but I don't think x will not. I don't think x will equal 10. If I got an even better idea. How about this? A equals 23. So as long as A equals like 23, and then we clear a line, that should just take us straight there. So if we play it now, okay. Now all we have to do is clear a line, which should be easy because we've got a straight piece next. So it should break. Oh, I know why it didn't break. Okay, so let's pause. Okay. So I think what might have happened was I so it might not do a decrement, it might do like a subtraction. So it subtracted 3, so it like completely skipped over. Oops. Okay, so I think I know what it did. That makes sense. Okay, so let's try this because I cleared more than one line. Let's try this. If a equals 20, because I know I can clear a line. Yeah, I didn't think of that. Okay. Let's try it now. It has to do it. Boom. All right. So, okay. Now that's so. Oh, you know what? I think I know why. Let's try this. So the 70 must be the copy value. So it's probably writing to 50 then. So we'll do a equals 19. Boom. All right. So this is getting fun, isn't it? All right. So now let's see what happens. All right, now remember, I have to like clear out just one line. Shit. This will work. Aha. Okay. So this is the code. Let's see. Oh. So this is like the special code that makes it that makes it like base 10 instead of but we're closer. Okay. So what we need to do is we need to figure out where. So let's see. LDA and then jump to. So we need to figure out where. Okay, so it might be a better idea if we. So we're on the right track. That's good. But let's do this one more time. But this time 18. And the reason why I want to do this is so that I get more of the normal code. So this is probably part of the line clearing routine or something. So yeah, there are many different places where it subtracts and then stores it in 50. So yeah, so okay, but we want to do this in like the most basic way possible. All right. So so we have it at 18. Again, we just need to get rid of one line. The Tetris gods have frowned upon me. All right. Boom. All right, so all right, so now what we need to do is we need to figure out how this code works. So the interesting thing is can we step back? That'd be kind of cool. So here's the call stack. So function at AC82, I think, is what calls whatever this is, and this does like the math to remove the line to lower the counter. So this is see, I was picturing this in my mind, a decrement, and a decrement's very easy to edit, but it's not. So this is where this gets loaded, and then this is set carry, and you need that for subtraction math. It's a long story, and then you okay. So A8 is the amount of yeah, A8 is the amount of I think lines cleared probably. Let me see. Boom. So it's probably this guy right here. Okay. So that's the amount of lines cleared. So what we would probably want to do is we need to figure out Like, okay, so, LDA. So that gets, let's see. But the problem that I have with this is, like, how to put this is this is only one case. Like, what if you go below zero, like we did last time? That's probably different. That's probably a different punch code. But if we were to like take this and change it into like we don't want to do like no op. That would be a bad idea. So we want to take we want to take this and change it in a way that will like negate it. So these are 2 bytes. We want to do one game Genie code. So what you could do is you could you could make it plus, but then you gotta deal with shit like rollover and whatnot. So I mean, technically, if you're starting off with 25 lines, this would work because you wouldn't have to worry about the whole like rolling over from 0 to 9, like the special case that has for that. So it would work. I just gotta like think what would be the best instruction to use in order to do that. So because okay, so LDA, we gotta find something that is that's always 0 because that would work very well. So what um that's an idea. So what you want to find is you'd want to find an always 0 memory address. That can be kind of difficult to find sometimes. So a lot of this would be like the stack. You don't want to fuck with that. So this everything here to like here is like the stack. You don't want to dick with that. Um, and that can go up to like I think all the way up here. But usually, um, I'm trying to think of a good place to do this. Unless anyone else has a better idea. Which any is worth that hard to understand the code. I mean, honestly, like all software, all games kind of boils down to, machine language, this sort of shit. And if anything, this is simple. Have you ever tried to read like Z80, like 6800 or MIPS or ARM or God forbid x86, which is like assembly on hell mode? So no. This is simple. You've got 3 registers. You've got conditional branches. You've got everything you need. So I don't think I want to do anything that dirty. Let me see here. We could. I don't want to store it in a weird ass place either. Um, maybe. Let's see here. I really wish there was just one instruction that I could like wipe. And I'm trying to think. What is um what is 50 in in uh in 6502, I wonder. Does anyone know? Because if I was to no-op that, 50 could just be like a bullshit instruction, but you run the risk of weird shit happening if you do that. Hmm. I'm trying. I'm gonna have to look at like an opcode list. Give me like 2 seconds. Um, I'm gonna like open up browsers and whatnot. So give me like two moments here. So I need to look at a 6502 opcode list. Hold on. We used to have like this opcode table. Here we are. So I need to take a look at this really quick here. BVC? Maybe. Let's see here. Because I need like some. So what's fit? Oh, 50. Yeah, 50 is BVC. So that's a branch instruction, I think. I think. Yeah, branch on overflow clear. You wouldn't want to do that. So it's like a multi-byte. Yeah, that would be bad. No, you wouldn't want to do that. So that's out of the question. Um, so the question that remains is, where would we want to put this? So there are a few. What's no-op? That'd be nice to know. No-op is EA, so that's not gonna work. Um, I'm just looking at my instruction options here. LSR roll store L to comp. Wouldn't want to do that either. Ink absolute absolute. Yeah, so that wouldn't be good either. Shit. Wouldn't want to push or pull. That'd be bad. Don't want to do bit. You don't want to really do bit math. That would be bad too. I don't have that many options for bullshit instructions. Let me think here. I think there are some like undefined instructions that like do weird things like a double nope, but I don't know if it increments the program counter by 2 or not. I guess you could do like a jump, but again, that would require 2 bytes at least. So that wouldn't work either. Let's see, flag instructions, clear carry. You could do that. I mean, it's not that good of an idea. But branch and carry, clear, branch, jump, return from jump routine. Yeah, I don't think it really gives any sort of yeah, no, yeah, I think I can't remember how the Nintendo handles unsupported instructions. Hello. Here. So I need to keep thinking about this. If you guys have any ideas, let me know. So basically, we're going to be modifying just about anything from here to here. So this is loading it in. Honestly, we probably don't want to modify anything there because it's going to be saving it there. This is just a set carry operation, so it's part of the subtraction. It's part of the subtraction operation, so can't really do much with that. Subtract. So we could set this to like 0, like if we were to change A8 to something else, and then or we could just do like take this and store it somewhere else. That doesn't matter. Either way, we're looking at more than 1 byte thing. My wife is showing me some. I think she wants me to stop because my voice is too loud. No, I'm not in a class. I'm teaching debugging. Yeah, so it's a little bit loud. Basically, I've got to take like a closer look at this, but you know, when you're married, there are agreements. So I think what we'll do is I'm gonna look over this code for a bit. Hopefully, I can figure something out. For those new to joining in from like Reddit and whatnot, I'll talk this over in the ROM corrupting channel in my Discord server. There should be a link in the description, I believe. So, but I gotta wrap this up. But also let me know if you want to see like more debugging in the future. That's just I forgot that it gets late here, so. But I wanted to just try this out. But in any case, yeah, just an experiment on and just a little tutorial on how to debug things. So in any case, see you guys later. Bye for now.